Okay, so continuing on, in Unit 3, we're going to talk about mole relationships in chemical equations. So a balanced chemical reaction tells how many moles of each reactant are needed and tells how many moles of each products will be produced. So in this example here, which let's check this equation out, is it balanced? It does not appear to be balanced, so let's balance it first. 1 aluminum, 2 aluminum, so I need to put a 2 here. 3 sulfurs, 3 sulfurs. Okay, so this tells us that we need 2 moles of aluminum to react with 3 moles of sulfur for this reaction to happen. So the reactants must be in a 2 to 3 ratio. So when you have a 2 to 3 ratio, you will produce 1 mole of aluminum sulfide. So if you double your aluminum, 4 moles of aluminum would need 6 moles of sulfur to react and would give 2 moles of aluminum sulfide. So we're just saying 2 times that, 2 times that, 2 times that. So you would have 2, 3, 1, so 4, 6, 2. And so if you do the same thing, if you increase the number of aluminum to 20, the number of moles of aluminum, so 2, 3, 1 is our balanced equation. So if you increase that to 20, then you would require 30 moles of sulfur, and that would produce 10 moles of aluminum sulfide. So on the next page, there are some practice questions. So using the following balanced reaction, 2 moles of sodium plus 1 mole of sodium gives you 1 mole of sodium sulfide. Calculate how many moles of sulfur are needed to react with 8 moles of sodium. So 8 moles of sodium. You can set this up like a conversion problem. So you're asking how many moles of sulfur are needed to react with 8 moles of sodium. So I'm taking these coefficients from right here. So it's a 2 to 1 ratio. So I have 2 moles of sodium to 1 mole of sulfur. So that would give you 4 moles of sulfur. Okay, so then if you go on to number 2, using the following balanced reaction, calculate how many moles of HCl are needed to react with 3 moles of zinc. So 3 moles of zinc is your starting quantity. And so my coefficient in front of zinc is 1. My coefficient in front of HCl is 2. So it's a 1 to 2 ratio. 1 mole of zinc, 2 moles of hydrochloric acid. So I get 6 moles of HCl. You go on to number 3, using the following balanced reaction. It's nice that these reactions are balanced, so you don't have to, it takes the guesswork out of it. Calculate how many moles of water are needed to react with 2 moles of calcium. So 2 moles of calcium over 1. Okay, so you're looking at these coefficients. It's hard to see that highlighting, huh? Okay, so 1 mole of calcium, 2 moles of water. So you end up with 4 moles of water. Now some of you might be wondering why I'm setting this up as a conversion, and you can do it in your head. If you can do it in your head and you're getting the right answer consistently, then by all means you can keep doing that. Sometimes it can get confusing, like when you have cases where you have to divide by something, and you can sometimes not do that in your head, so you just have to be careful. Okay, 2 moles, so using the following balanced reaction, Calculate how many moles of lithium hydroxide will be produced from 2. So we're looking at these coefficients here. And I will circle this. Okay. So 2 moles of lithium nitride over 1. And so 1 mole of lithium nitride produces 3 moles of lithium hydroxide. So you get 6 moles of lithium hydroxide. Okay, and then we have another practice problem. The last one, using the following balanced reaction, calculate how many moles of HNO3 would be produced from 9 moles of NO2. So we're looking for HNO3. See, this is one where you do it in your head, you can get it mixed up. But again, if you have a system that works, keep doing it. Okay, so you get 3 times 2, so 6 moles of HNO3. Okay, so that concludes mole relationships and chemical equations. The next lecture will cover mass relationships and chemical equations. Until next time.